library. Alright, we got our tools all set up in the tool library, all ready to go. So it's time to move on to the next step. Step number 4, programming the part. I'm going to show you standing right here in front of the control in just a few minutes of how to program this part. I'm going to use Centroid's Intercon, which stands for Interactive Conversational Programming Software. What Intercon is going to do for us is it's going to prompt us for the dimensions off our print, and then Intercon will automatically generate the G-codes necessary to machine this part. In addition to Intercon being available on the control, you can also get it for use on your desktop PC. To start programming in Intercon, press the F5 CAM button from the main screen of the control. CAM stands for Computer Aided Machining. When Intercon starts, it automatically loads the last job that you were working on. Well, we want to do a new job, so I'm going to hit the F1 File button, and it gives us a bunch of choices here to load an existing job or save the existing program that we're working on. Well, F1 says New. That's what I want to hit, the F1 New button, to do a new program, and it asks us for the name of the new program. So I'm going to type in CAM, C-A-M. You can use any combinations of letters and numbers here to name your particular program, whatever you want. Once I've typed the name in, I can hit the F10 Accept button, and Intercon starts a new program. So here we are at the beginning, and Intercon would like to know the initials of whoever's programming this part, so I'm going to type my initials in. And when I'm done typing anything in, I'm going to hit the Enter button to insert that information into that line. The next line is a nice feature, is the program description line. You can leave this blank, or what I do is I add in a further description describing what exactly is this program that I'm creating. It's a nice feature because when you come back 6 months from now and you have a big long list of programs, this description will be here in addition to the program name, and will give you a better idea of what exactly you're looking at. So I'm going to go ahead and type in CAM4 training on this particular one. Once I've typed all the information in, what I want to do is hit the F10 Accept button. What that does is it takes the information that we typed in and stuffs it into the line that currently has a rectangle around it, which in this case is line 1, the header, which is the beginning of the program. So I'm going to go ahead and do that. I hit F10. It took that information and stuffed it into line 1. Now you'll notice that it's inserted a blank line in between the first and the last line of the program, and it's simply asking us, select the operation you want to insert. And there's a whole bunch of choices down at the bottom. Choices like rapid to a position, linear mill, arc mill, tool change, can cycles. There's a whole bunch of stuff in there we're going to come back and talk about. Well, the first thing I want to do is center drill these holes, that bolt hole circle, on my print. So the very, very first thing you do, even before you go program the drilling cycle, is you got to do the tool change. You got to get the tool that you want to use. Well, remember, tool number 1 was our center drill. So I'm going to go do a tool change, hit F4 to do a tool change to tool number 1. So all I have to do is hit number 1 right there and then enter. And you'll notice that Intercon goes and grabs the information out of the tool library. So the height and the diameter offset are here. Also, the position in which the tool change will take place is here. And information like what spindle speed and what direction and flood is all right here. I can change any of these things that I want right now, or I can leave them alone if they're fine. Well, let's go down and talk about the position. The position, this is the position in which the tool change will take place. Well, remember, we decided that X0, Y0 was going to be in the center of our circular pocket in our bolt hole circle. So right now, the tool change position is set at 0, 0. That means the tool change will actually take place above 0, 0. That's fine in this particular case because we have a bed mill with lots of Z travel, so it's not going to be a problem to actually have the tool change take place directly above the part. If you didn't have a machine that had as much Z travel, you might want to make your tool change somewhere away from the X, Y, 0 position of your particular part. You might want to come over 5 inches and up 5 inches. Well, that's where you would type this number in right here for that type of tool change. In this case, we're going to go ahead and leave the tool change at 0 for X and Y. Here's the tool diameter. That's just the information out of the tool library. It looks good. Here's the spindle RPM. Now, if you have an inverter-equipped machine, which most machines today are, this is where it gets its information on how fast the spindle for this particular tool. We have it set to 3,000 RPM. That's fine right now. It's also set for clockwise. And this reminds me, anytime you see a word lit up in Intercon anywhere, you hit the F3 toggle button and you can toggle through your choices. In this case, there's 3 choices for spindle direction. It's clockwise, counterclockwise, and off. Well, I want to make sure that it's set to clockwise for tool 1. And I'm going to make sure that the coolant is turned off. I don't need any flood coolant to do some center drilling. And I'm going to go ahead and hit accept F10. It'll take this information and stuff it over here in the line number 2. There you see tool number 1. Now it's asking us, hey, what do you want to do with tool number 1? Select an operation. And that's back down to all our different choices. Well, we want to do some center drilling on this bowhole circle. So under can cycles, F5, I'm going to find a whole bunch of nice can cycles. Here's drilling, boring, tapping, facing, rectangular pocket, circular pocket, frame mill, thread mill, and irregular pocket cleanout. Well, I'm going to be doing some drilling with that center drill, so I'm going to hit F1 into the drilling menu, and I have 4 more choices in here. Drill a hole, drill a bowhole circle, drill an array, or do a repeat drilling cycle. Well, we're doing a bowhole circle, so I'm going to hit F2. Now, the information that it needs to know to drill a bowhole circle shows up on the right-hand side. These are the questions that we have to answer to center drill this bowhole circle. First question it wants to know is the cycle type. What type of drilling are we going to use? Well, again, the F3 toggle button toggles through the 3 different types of drilling cycles that are here. There's drilling, deep hole, and chip breaking. Well, I'm going to go ahead and just use a regular drilling cycle, because what that does is it feed rates down and rapids out of the hole. And for center drilling, that's all you need. I don't need to use a chip breaking or a deep hole cycle for center drilling, since we're drilling at such a shallow depth. The next question it wants to know is, where is the center position of that bowhole circle? Well, again, here's our bowhole circle. Where's the center? X0, Y0. So I just make sure that X reads 0 and Y reads 0 for this particular case. Now, if that bowhole circle was out here, you would measure the distance from X0, Y0 to that bowhole circle. Remember, everything right now is in absolute positioning. Everything's measured from this particular point. We've made our life easy because we've picked our X0, Y0 to be in the center of that bowhole circle. So I'm going to go ahead and leave X set to 0 and Y set to 0. The next question it wants to know is surface height. Well, I'm really not quite sure what surface height is. So what I can do is I can hit the F5 help button, and a nice graphical display shows up on the left-hand side of the screen of whatever you're working on. So for all the operations inside of Intercon, you have a graphical help screen that helps you understand what it's asking for, what kind of information it needs to know to do that machining operation. These are also all in the manual, so you could open up the manual and look at these as well. Well, the surface height is simply where is the top of the hole relative to Z0. Well, remember, in step number 1, we decided that the top of our part is Z0, so our holes start at the top of the part. So the top of the holes and the top of the part are both Z0, so that's our surface height to Z0. So we can just leave the surface height set at 0. The next question it wants to know is the clearance height. Well, since we're drilling 5 holes on this particular part, when I'm done drilling the first hole, it wants to know how high to lift the tool to machine over and to move over to machine the next